First, if we look at the Arduino, we can see that it has numbers written on it, and it is marked as analog. There are also labels indicating digital, along with the corresponding numbers. This labeling makes it easy for the general public to identify which pins are digital and which are analog input pins. In practice, if you find that you are running out of digital, output or input pins, you can also use the pins labeled as analog input for digital, output, or input. However, it is advisable to avoid using pins 0 and 1 as much as possible. This is because, in the case of Arduino, the communication with the PC regarding firmware and such is done via UART, and the communication lines for that UART are connected to pins 0 and 1. If you follow this link now, you can see the circuit diagram of the Arduino Uno revision 3. Here, the pins 0 and 1 correspond to PD0 and PD1 of the ATmega 388PU, and you will clearly see that they are connected to the TXD and RXD of the USB driver, the ATmega 16U2. So, it's better to avoid using pins 0 and 1 as much as possible, because these pins are often used for serial communication, which can interfere with your program if not handled correctly. Let's run the Arduino and write some code to control the digital output, which is a fundamental aspect of working with microcontrollers. This won't just end with simply saying that we can control the digital output. I will also show you how I actually write the code step by step, ensuring you understand each part of the process. In my case, I will use pin 8 to turn an LED on and off, which is a common beginner project to get familiar with digital outputs. So, I will define a macro like this. Define pin LED 8, which makes the code more readable and easier to maintain. After that, for digital output, I need to set the direction of the pin, which determines whether it will be an input or an output. I will set it as mode pin LEDs out, which configures the pin as an output. Then, I will turn the LED on and off every second to create a blinking effect, which is a simple yet effective way to test the functionality of the pin. So I will use digital write pin LED high to turn it on, followed by a delay to keep it on for a second before turning it off again. Since it's in milliseconds, 1000 means 1 second. If you copy and do it like this, blow, it will turn on, wait for 1 second, turn off, wait for 1 second, and this is an infinite loop, so it will keep repeating. However, in this case, when I just typed, the lines got misaligned. This is called indentation, and when the lines are misaligned, if you press Ctrl-T or Command-T on a Mac, it will automatically format the lines for you. If you click OK in this state, I will save it first. By clicking OK, it will compile and check for any issues. In this state, if you click the Upload button, it will upload to the Arduino. In other places, it might be called download, but here it is referred to as upload, meaning it has been uploaded to the Arduino. Similarly, for digital output, you set the pin mode to output and use digital write. Delay, and digital write again to set the pin number to high or low to turn it on and off. Next, I will write some code for digital input. Digital input is a fundamental concept in electronics and programming, where we deal with binary signals. In the case of digital input, there are various things like pressing a button or receiving input from a PIR sensor. These inputs are crucial for interacting with the physical world. Let's assume we are using that as a basis. For this example, I will consider using pin 9. Pin 9 is a versatile pin that can be used for various purposes. I will connect the switch to pin 9. In my case, I will set the macro constant for the switch to 9. This makes the code more readable and easier to maintain. Then I will set the pin mode for the switch to input. But this depends on the hardware connection. If the switch is physically connected with a pull-up or pull-down resistor, you can set it as input accordingly. This ensures that the switch operates correctly and avoids floating states. If you don't want to connect any external pull-up or pull-down resistors and just want to set the internal pull-up, you can set it as input pull-up. This way, the internal pull-up is configured and you don't need to connect anything. The initial state will be high. You can set it up like this. In my case, if I want to check the switch, I create a variable. In WinPy, I use pState, where low is generally 0 and high is 1. This is a macro constant, and as we saw last time, for fixed constants in programming, it's best to write them in uppercase with underscores, like input prop. The same goes for macro constants. For regular variables, we use camel case, and in my case, I start with a P. I have named it pState. The reason I called it pState is to indicate the previous state. Value, which is meant to inform about the previous state of the button. Here it is high instead of low because the switch uses an internal pull-up, so the initial state is naturally high. To be precise, it would be correct to do it this way. Because we cannot know the state of the switch when the hardware is turned on or off. In this state, I would suggest using either K or byte, but I personally have a habit of using uint8.t, uint16t, and so on for input. This is because using these data types makes it clear what kind of data I am working with, not just in Arduino, but also in other C or C++ programming. In this case, we are using an 8-bit data type. So I assume we are using an 8-bit data type that only represents positive values without negative signs. Therefore, I tend to use data types like uint8.t, uint16t, uint32t, or int8t. After doing this, I read the state using digital red pins set up the switch like this, and when the loop repeats, it will lose the value of the button. This is because the loop is designed to reset certain values, including the button state, each time it runs. Then enter the if statement. Here, if pState was the initial state, but the state is low because it was pressed down and connected to ground, then it has become low. This means it is pressed, and at that time you would set the digital light pin for the LED to high. If not, the pState was indeed low, but the state was currently high. Conversely, if the previous state was pressed, it should now definitely be activated as a button. So I will turn off the LED and then check it approximately every 10 ms to ensure it is functioning correctly. Of course, I need to update the pState variable to reflect the current state. So I will write the code like this to achieve the desired functionality. Looking at the whole setup, I have defined two macro constants related to the LED and switch, and then used a variable to check for changes in the button's relative value. I set the pin mode for the LED and switch with the LED as output, and the switch configured with an internal pull-up, or for easier connection, setting it as input pull-up. I used P-state because there might be a situation where the switch is already pressed when booting up. So I set the pin switch in digital read, and then in the loop, each time it repeats, I have a state variable to read the value of the pin switch using digital read to determine if it is digital high or low. If the previous P state was high and the current state is low, it indicates that the button has been pressed, so the LED will turn on. If the previous state value was low and the current state value is high, it means the button has been released, so the LED should be turned off. Then, update the previous state value based on the current state value, wait for 10 minutes, and continue this process. After organizing the code lines, press Command T to tidy up the lines, check it, and then upload. You can control digital, output, and input. In this session, we use the Arduino GPIO pins to control digital output and input. In the next session, we will use the Arduino GPIO pins to work on analog output and input. See you next time.